In the last video, we talked about vectors, and we talked about adding vectors, and we talked about multiplying by constants, but we didn't talk about multiplying vectors at all. And there's actually two different ways to do that. And the next two videos are going to cover those kind of two different multiplications of vectors. So the first one is called a dot product. And the definition of a dot product, if you take a vector, A, B, C, notice I'm taking a three-dimensional one, but you could do this with a two-dimensional one, and you dot it with D, E, F, then you multiply each component and add all of those multiples together. So you multiply A times D, and you add to it the multiplication of the y components, B times E, and then you add to it the multiplication of the z components, C times F. Right? So that's how a dot product works. Out of this, you're going to get a number. So the dot product gives a scalar, so it gives a number out of the end of this, which is going to be different from cross product. Cross product is going to give us a vector. There's a relationship with length. So if we take a vector times itself, so let's say we take A, B, C and dot it with A, B, C, then that would be equal to, not a vector, it's equal to A squared plus B squared plus C squared. And the magnitude of that vector V would have been the square root of A squared plus B squared plus C squared. Remember from the last video, showed you how to find magnitude. It uses the Pythagorean theorem. And so notice that if you take V and dot it with itself, you get the magnitude of that vector squared. So that's just one relationship with magnitude. Another thing that we can do with a dot product is we could find the cosine of the angle between two vectors by taking their dot product, so V dot W, and then dividing by the magnitude of each one of those vectors. So this kind of graphically, if you have a vector V and then some other vector W, you could find the cosine of the angle between them. And this gives us another really important result, that V and W are perpendicular. And other words for perpendicular are normal or orthogonal. Those are both words that also mean perpendicular. So V and W are orthogonal vectors if and only if the dot product of V and W is equal to 0. Right, this is an important one. We're gonna use this one quite a little bit. So V and W are perpendicular if and only if their dot product is 0, meaning if the dot product's 0, they're perpendicular, or if we know they're perpendicular, their dot product is going to be 0. All right, let's do a couple of examples. So let's take the vector V to be negative k, and the vector W to be I plus root 2 j plus k. I sometimes switch to hats too. It doesn't matter whether you use hats or arrows on this. All right, so this is notation that I introduced very briefly on the last one. It's I, J, K notation, and all it's saying is that, let me start with W here. It's saying in that kind of bracket notation that 1 is the component of the x component, because that's out in front of I. Root 2 is the j component, and 1 is the k component. Those are the numbers out in front of I, j, and k. And so there is no I and j on this one, so both of those components are 0, and then the k component is -1. All right, so I just wanted to kind of point out the IJK notation and show you something that's a little bit different. All right, let's find the dot product. So the dot product, if we take 0, 0, -1, and dot it with 1 root 2, 1, then we get 0 times 1. I just did that again. I didn't mean to. 0 times 1 is 0, plus 0 times root 2 is 0, plus -1 times -1 is -1, and so our dot product is -1. Now, this means that they are not perpendicular. The dot product was not 0. V dot W is not equal to 0, but we can find the angle between them. It's not going to be 90 degrees, but we could find the cosine of the angle is V dot W over the magnitude of V, magnitude of W. And we just found that the dot product was -1. The magnitude of V is the square root of 0 squared plus 0 squared plus -1 squared. And the magnitude of W is 1 squared plus root 2 squared, which is 2, plus 1 squared, which is 1. So we get -1 over 1 times 2, 3, 4, root 4, which is 2. So we get -1/2. So if the cosine of the angle is 1/2, then what's theta? So if the cosine, so you'd have to think of your unit circle. So it's going to be past pi over 2. It's going to be in that second quadrant. And it would have to be 2 pi over 3. So the cosine of theta was -1/2, and so theta is going to be 2 pi over 3.